Hello. In this video, we are going to do an application problem using vectors. So let's read the problem. A ship sails north 80 degrees east for 120 nautical miles. Notice we have a direction and a magnitude. And then south 20 degrees west for 200 nautical miles. How far is the ship from where it started and in what direction? So they're asking us to find the magnitude and direction of the resultant vector. All right, so a couple of things. We've got two pieces of information. We've got the ship going north 80 degrees east for 120 miles and south 20 degrees west for 200 miles. When we say north 80 degrees east, that means we go 80 degrees to the east. Whereas south 20 degrees west means we're going 20 degrees to the left or west of south. So at each of our origins or initial points for our vectors, we will draw a little set of crosshairs, right? A little set of axes to help us understand what we're drawing. So I'm going to start over here. Here's my first crosshairs, starting at this point. And we want to travel north 80 degrees east. So north 80 degrees east would look roughly like this. I'm going to draw this vector to be 120 miles. There's my 80 degrees to the east of north angle. So we went to this point. We stop here at this next point and we create another set of crosshairs. In this situation, now we're going to travel south 20 degrees west. So 20 degrees is just a little bit to the west of south. And I'm going to draw this vector a little longer. Again, your pictures are not always going to be to scale when you're drawing them, especially the first time you've drawn them. Mine looks really nice because I've drawn this picture a lot. So I've got that 20-degree angle in there, and then 200 miles. So this is the point, this is my terminal point where I am. And the question says, how far is the ship from where it started and in what direction? If we think about this, we started at A, we went to B, and then we went to C. So that resultant is from A to C, from the initial point to the terminal point. So we're looking for both the magnitude of the length and then the direction from initially where we started. So that would be this angle right in here between this purple line and this gray vertical axis. All right, so how are we going to do this? Well, these problems can be a little bit tricky for us to figure out, especially the first time around. One thing that I can discern is that this little angle right here is 10 degrees, because I know 80 plus 10 is going to equal 90. Now, if this little angle is 10 degrees, then up here, between B, between that horizontal axis and my red vector, that little angle is also 10 degrees. So if this is 10 and this is 20, the angle between them is going to be 60, because 10 plus 60 plus 20 will give us 90. So I'm going to put a 60-degree angle right there. All right, so now I've got some makings of a triangle. I have a side, I have an internal angle on my triangle, and a side. Side, included angle, side. This is a side angle side triangle, and side angle side means we use the law of cosines. So I always, after I've drawn my picture, I like to kind of, pull a triangle out, try and make it look the same. We've got 120, 60, and 200. And I've already labeled this triangle with A, B, and C. Now, the angle I need, or the angle I might want to know, would be this angle here, A. I'm mostly interested in angle A because angle A is going to help me get the angle from my initial position. And then we also need the length of this purple side, side B. So we need to use law of cosines to find side B as well as angle A. So angle C, we'll be able to find that by subtracting the two angles, but it's not necessary in this situation. So working to find side B, my patterning using law of sines would be that B squared equals A squared plus C squared minus 2AC times the cosine of B. And I'm going to go ahead and isolate that and put my square root over here. So I've got equals the square root of all of that. This should be pretty easy. We'll just plug our numbers in and get an output value. Since A is 200 and C is 120, 200 squared plus 120 squared minus 2 times 200 times 120 times cosine of the included angle, which is 60. That calculation gives us that B is equal, little b, the side B is equal to the square root of 30,400, or that B is roughly 174 nautical miles. So now we know the magnitude. We know how far away we are from this initial point. The length of my resultant vector from A to C is roughly 174 nautical miles. And remember, you just need to round to whatever's specified in MyMathLab or on your homework or on your lab. Just pay attention to that when you're working through the problem. So now let's focus on angle A. Now, my setup for law of cosines, if I was interested in angle A, would be A squared equals B squared plus C squared minus 2BC times the cosine of A. And we've done this several times before, but I would subtract my B and C, divide by the coefficient of cosine, and then get inverse cosine to find that A is inverse cosine of the quantity A squared minus B squared minus C squared divided by negative 2BC. One thing to keep in mind when we're plugging in B squared here. Now I took the square root. We said that B was equal to the square root of 3,400, right? B equals the square root of 30,400. So that means B squared is equal to 30,400. I have an exact value that I can use. All right, so we use that for B. I'm going to plug these values in. I have A is cosine inverse of A squared, 200 squared, minus 30,400 minus 120 squared, all divided by negative 2. Now, B is just the square root, so I've got the square root of 3,400 times 120. So that's a nice, easy way that we can plug that in exactly. And we end up with that A is roughly 83.41322. There are more decimal places than that, but I've rounded. You must be in degree mode. So A is 83.4 degrees. All right, so I'm going to clean this up and go back up so we can see our picture a little bit better. So we know this angle is 83. This whole angle here between the red line and the purple line is 83. So what is just this piece right here? Well, if we know that little sliver is 10, then this angle is 73.4, because I can take 10, I'll take that little 10, which we had showing up right there, away from the 83.4. And then if I need to determine what this angle measure is right here, well, we're inside this 90-degree angle. So if this is 73, then this is going to be 16.6. 73.4 take away 90 gives me that this angle is 16.6 degrees. So to answer our question, we have sailed, we are 174 nautical miles away. And how are we going to say that direction? Well, we are in the direction south. I'm going to round to 1 decimal place and say 17 degrees, south 17 degrees to the east, because we're off of south 17 degrees to the east. And that is from my original or starting point. So we're 174 miles away in the direction south 17 degrees east. All right, so we're all done in this problem. We did a problem, an application problem where we used vectors to create a triangle. All right, if you have any questions, send me an email. Good luck out there.